And please open it again for questions. Good. So,
Any questions?
presentations open for discussion. What do you learn from molecular orbitals? Why do you want to plot them? Is there anything valuable in addition to that they look nice?
Doesn't it show like where the electrons are in the molecule?
Okay. Are they at the same place for each orbital?
No.
Can you expand on this? And I know that there is a person in the audience who can help.
If you can help me, that'd be nice.
Can you repeat the question?
Can you please repeat the
If
question?
you said if the electrons are in the same place, they're not.
So, as a result of electronic structure calculation, Paulina told us that we can generate multiple orbitals. And Kelly showed us that there are occupied, unoccupied orbitals, and probably if you look on their shapes, the shapes will be different. And according to Paulina, the shapes of these orbitals tell where electrons are residing. So, what can we learn if we believe that in one orbital electrons reside in one group of atoms, in another orbital electrons reside on another group of atoms? So what does it tell us? Which chemical property?
Would it be like related to, so what can electrons do in a chemical reaction? So like oxidation, reduction, that kind of stuff. If you have something that you want to, expose to oxidizing conditions, so if you're trying to oxidize it, the loss of electrons, so you can visualize where the electron density is, where your highest occupied molecular orbitals are, right? And the molecule that you showed is pretty non-polar, so it kind of looks like, well, I guess that's not totally true. So what do those different colors mean?
The blue is where it's the lowest electron density, the red is where the highest electron density is. So in the red, it's where all the electrons are residing. Not all of them, but most of them. Right? Yes.
Yeah, I'm fine with that. So, let me try to answer, try to help you both to answer my own question. It could be interesting for all of us. So, there are oxidizers, acceptors of electrons, and there are reducing agents, donors of electrons. And typically, if they're brought together, one may expect that occupied orbitals will belong to the space region of oxidizers, because oxidizers pull electrons. And the empty orbitals, unoccupied, will correspond to reducing agents, to donors. So if you have a group that is predominantly donor, and you look on the lowest unoccupied orbital, it should be there. And one of the examples, if you do not have the strontium, just titanium dioxide, then the HOMO should be on oxygen, and LUMO is expected to be on titanium, because oxygen oxidizes titanium. And it is one of the form of information that can be learned by looking at the orbitals. It should be different way. One of the questions and answers from the speaker. Anyone who wants to ask more questions to the speaker? No? Okay, let's thank Paulina for a nice